This worksheet is giving you a chance to practice naming ionic compounds. So if you read the first part over here, this describes two methods to name ionic compounds. And then over here, I have several parts, but in this one here, you're going to fill the blanks, and you're going to identify the cation, anion, as well as name the ionic compound. Now, how I'm going to do this is I'm going to go over how to name the first element. This one right here, and then next what I'm going to do is I'm going to pause and give you a chance to try naming these, and then I'm going to go over and I'm going to answer each one of these. And what you can do is you can check to make sure that you understand that you have the correct answer, and you understand how to name these ionic compounds. Okay, and I would recommend that you do pause and try and fill in the answers without looking at the answers first. And so what you do is when I get to do the first example, pause it, write down the name for for this right here, and then what I'll do is you can pause it, then I'll go over the answers for the next one, and so on and so forth. Okay, so let's look at the first one. So we have the chemical formula here, and what I'm going to do is I'm going to name the cation. And so remember, the cation has a positive charge, and then I'm going to name the anion, which has the negative charge. And in ionic compounds, generally the first element in the compound is positive, and the second element is negative. So in other words, the first element is going to be the cation, and the second one's going to be anion. So here, if I go look in the periodic table, I'll find that Li is lithium. So the first element is lithium. And then when we use the name to just name the ion, we put the word ion after it. So the cation, Cl, is chlorine. But what I'm going to do is I'm going to drop the ending of the element name, and I'm going to add IDE to the end of the name. So instead of being chlorine, it's going to be chloride ion. Now what I'm going to do when I name the compound is I'm going to combine the two. So if you look at the instructions, combine the name of the positive ion, and don't include the word ion, and then the negative ion, and the name cation first, and then the name anion. So it's going to be lithium. Yeah, I'm not going to put the word ion. And then chloride. Okay, so now pause the video, and we'll go over the next one. Okay, so let's look at the second one. The cation is calcium. So we're going to write calcium and then write the word ion after. And then the anion is chloride. And so we drop the ending and add IDE and add the word ion. And then we put them together without the words ion, and you have calcium chloride. So pause the video again and try the next one. So if you look at the next one, the cation is aluminum ion, and then the anion is fluoride ion, and then the name is, you put together the aluminum and the fluoride, and you got aluminum fluoride. All right, let's look at this next one. So the cation is iron, Fe. And ion. And then you have the second element, the anion, is chloride. Ion. Okay? Now, one thing you notice here is that if you look at this one here, FeCl2 and FeCl3. So iron has two possible choices as far as charges. There's an iron with a 2 plus charge, another iron with a 3 plus charge. So we need to distinguish which iron is in this element. In this compound. So if you look at the charge of chlorine, the chloride ion has a charge of -1. Okay, so chlorine is -1. That's not very clear. Try that again. All right. So your chloride ion has a -1 charge. So if we have iron and two chlorides, that means that the iron must have a +2 charge, because if you have two chlorine ions, that means you have two negative charges. So this is going to be iron, and I'm going to put the charge of the iron in parentheses, 2, Roman numeral, and then chloride. All right, so this Roman numeral is telling me the charge of this iron. And then the word iron, I didn't make that very clear. Let me try that. Writing that again. So iron, 2 chloride. All right, try the next one. In this next one, remember, you have iron, and then you have 3 chlorines, and you have a choice of either iron 2 or iron 3. So pick which one you think is here. Write down the name of the cation, the anion, and then the full ionic compound. So what you see for this next one is that it's still on, the first cation is still iron ion, and then the next one's chloride ion. But when we write down the full name iron, we're using a +3 charge, because there's 3 chloride ions. So that's 3 negative charges. They have to be balanced by the +3 of the iron. Okay, so pause the video, and what I'm going to do is I'm going to write the answers for the remainder of them. So when you restart the video, what you'll see the answers for all these. So you try them and see what you have for answers and compare it to what I have, and then you can see if there was any mistakes that you made. Okay, so if you look at them, CuO, you have the copper ion, and then you have the oxide ion, and then since we have two choices as far as the ions for iron, either iron 2 or iron 3, copper 2 or copper 1, I'm going to have copper 2 oxide. And then the next one, you have the same thing, copper ion, and then the oxide ion, but instead it's going to be copper 1 oxide. Now next one, KBr, potassium is the first element, right? That's the cation, and the bromide ion is the second element. You put it together, you get potassium bromide. Now the next one, barium is the first one, barium ion, That's your cation. And then you have the bromide ion, which is your second element. And you put it together, you got barium bromide. And the last one, calcium is your cation, and then nitride ion is your anion. You put it together, you get calcium nitride. Now on part 2, write the formula and then write the ionic compound. So I've given you the anion and cation for each one of these. What you're going to do is you're going to put them together to write the formula and then write down the name. So let's look at the first one. You have chromium, and if you look, it has a charge of 3 plus. And then you have the chloride ion, Cl, negative 1 charge. And then when I wrote the answer, I have chromium, one of them, and then I have 3 chlorides. Why do I have 3 chlorides? Because the chromium has a plus 3 charge, and each of the chloride ion has a negative 1 charge. So I need 3 of the negative charges to balance out the 3 positive charges. And then you have, if you want to name it, now remember, if you look at the chromium, and you actually go down to this table down here, so go down to look at this table down here, what you'll see with the chromium is that there are 2 possible ions, chromium 3 plus and chromium 6 plus. So when I write down the name, I need to indicate which of those ions it is. So in this case, it's the chromium 3. So I'm going to write down chromium, and then in parentheses, I'm going to put down 3 in Roman numerals, put parentheses, close it, and then write down the anion, which is going to be my chloride. So I have chromium 3 chloride. Now I'm going to I pause the video now, and then what I'll do is I'm going to write down the answers. So when you start the video back up, you'll see the answers. Compare them to what you have, and see any errors that you're making. Okay, so if we look at the second one, you have the iron and the chloride ion. So iron, yeah. Iron, ion, chloride ion. I write it out. I have Fe of Cl3. Now, if you recall, one of the methodologies for figuring out the number of each one of these elements is I can do a crossing of the charges. So I'll take the charge for the iron and use that as the subscript for the chloride ion. And the chloride ion, I'll take the 1 and use that for the iron. So you got Fe, and there's only 1. I don't have to write the subscript, not 1, because it's understood. And then there's 3 chlorides. And the next one, you have the calcium. Sorry, I'm going to have to name that too. Iron 3 chloride, because there's more than one charge that iron can have, so I'm going to indicate that by putting the charge in Roman numerals. And then you have the chloride ion, so iron 3 chloride. Now next one, calcium and nitrogen. You look at the charges, calcium is a +2, nitrogen is a -3. I'm going to cross the charge. In other words, I'm going to use the positive charge, the charge of the calcium, and use that as the subscript for the nitrogen. All right, so 2, and then I'm going to use the 3 from the nitrogen as the subscript for the calcium. So if you look at if you do the multiplication, 3 times +2 is 6, so you have a total +6, and then 2 times 3 on here is -6. So that's how we get calcium 3, nitrogen 2, and right at the name, calcium chloride. Now the next one, you have potassium with a positive 1 charge and oxygen with a negative 2 charge. So I have to have 2 potassium and 1 oxygen for there to be a net neutral charge. So calcium 2 oxide, calcium and the oxygen, so calcium oxide. I said calcium, potassium oxide is the name. Okay, next one, iron 3 and sulfur with negative 2. So I cross the charges. So I'm going to use the charge for the iron as the subscript for the sulfur, and the 2 negative charge. So the 2 of the sulfur I'm going to use as the subscript for the iron. So you have Fe2S3. And then I write that out, iron 3 sulfide. Why did I put down the 3 in there? Because we said iron has more than 1 potential charge. And if you look at the table down here, right? If you look at iron, you have an Fe2 plus charge or a 3 plus charge. So in here I'm indicating that the iron has a 3 charge and then sulfide. The next one's fairly simple. You have lithium and oxygen. So Li2O, lithium oxide. Now this next one, you have chromium with a 6 plus charge, and then chlorine with a negative 1 charge. So the chromium and the chloride ion, their charges need to be to cancel each other out. So I have 1 chromium and 6 chlorides. And when I write out the name, I need to indicate the number, the charge of the chromium. So it's going to be chromium 6 chloride. So this page of the homework assignment, we're going to be working on naming polyatomic ions. So first of all, polyatomic ion is a group of covalently bonded atoms with a charge. And anytime we use or write a formula using polyatomic ions, we're going to treat the polyatomic ion as if it was one individual ion. Okay, so when you name them, you name the cation first, and then the anion, just like we did with the other ionic compounds. Let's take a look at one. So this part 3 over here, if you look at the first one, HCN, H is for hydrogen, so we would name the cation hydrogen ion. And then CN, right, I'm going to put it over here, write the symbols here. So H is for hydrogen, and CN is for cyanide. Now something to keep in mind is that hydrogen has a positive 1 charge, and cyanide ion has a negative 1 charge. All right, so in order to, if we were going to actually write out the formula for it, you would have HCN, we would write HCN 1 hydrogen 1 cyanide ion, because the charge is positive 1 and negative 1, so you'll need 1 of each. And then we write the name hydrogen cyanide. We take away the ion, the name ion, and just say hydrogen cyanide. Now the next one is you have this Fe, SO4, and Fe is iron. So that's my cation, and then SO4 is sulfate. And our sulfate ion has a charge of -2. So I'm going to put over here. So the first one is iron. So your iron ion. And then you have the sulfate. Ion. And it's a polyatomic ion, but it's still an ion. Those are going to treat those group of atoms bonded together covalently. We're going to treat it as if it was an individual ion. Now, When we write the formula over here, we need to know what the charge of the iron is. So let's take a look at what are the two possible charges for iron. Iron can have a charge, so Fe. It can have a charge of +2, or it can have a charge of +3. So we have to figure out which one we're going to use on here. So since the sulfide ion has a -2, right, and we only have one of each, that means we have to have only one of the iron, which has a +1 charge. So when we write the formula, it's just going to be iron, all right, and +2 charge, sulfate, iron 2 sulfate. So at this point, you should try these on your own. So pause the video, try and name the cation and anion and name of the compound for each of these. And then restart the video, and I will write down the name of the cation and anion for each one of them, as well as the name of the compound, and you can see how you did. And don't be afraid to try, even if you're not certain, because if you have it wrong, that just allows you to see where you made a mistake and what you need to change, because you always can try this over again. All right, good luck. So now I wrote down the answers for the remaining polyatomic ions containing compounds in part 3. Now, if we look at this one here, the Fe2SO4 the first one is the iron ion, and then you have the sulfate ion. Now, I wrote iron 3 sulfate. Why is that? Because if you look at the sulfate, there's 3 of them. That means that's a -6 for a total charge. And there's 2 irons. In order to have a +6 charge to neutral, they have to have irons with a +3 charge. So iron 3 sulfate. Now, next one's sodium ion, right? And the NO2 is the nitrite ion. And then when we put it together, we have sodium nitrite. And the next one, the NH4, ammonium, and then chloride, ammonium, and then a chloride ion. When we put it together, we get ammonium chloride. Next one, NH4, that's ammonium again, and then we have PO4, phosphate. So this is 2 polyatomic ions that put together. So the first one is the ammonium ion, remember that has a positive charge, and the phosphate ion, which has a negative charge, and we have ammonium phosphate. Finally, the Cr2 is chromium ion, and then the Cr4 subscript 3. So there's 3 of these chromates. So we have the chromate ion. Now, when I write this out, I had to write down the charge of the chromium. In order to do that, I have to figure out what the charge is here. So the chromate, the charge doesn't vary. So I'm going to look at that one first. And when I look at the chart, it's -2. That means, and there's 3 of them, means I have a total of a -6 charge. And I have 2 chromates. 2 into 6 is 3. So it has to be a +3. So that's why I did chromium 3 chromate. Okay, now part 4, write the formula using the cation and anion, and then name the compound in the table below. So you can use this same strategy that I used in part 3. But here you have to write the formula. So you need the to figure out the charges as well as the number of the cation and anion when you write the formula. So let's look at the first one, sodium, and then the chromate ion. The sodium has a positive 1 charge, and the chromate has a negative 2 charge. If you remember, and I'll write it down here, Na plus, and I'm going to combine that with CrO4, 2 negative, and the sodium is understood to be 1. So a trick to this is you can cross the charges and use the number. So I need to have 1 chromate, and I have 2 sodium. So it would be Na2CrO4 would be my formula. All right, and then we put the cation together and the anion together to form the name sodium chromate. Now let's look at the next one, Mg. So if I look at, well, what is that? That's magnesium. And then NO3. If I look at NO3, that's nitrate. Okay. Now writing the formula, this one's pretty easy because the charge is positive 1 for the magnesium and negative 1 for the nitrate. So I'm going to just need 1 of each. So it's going to be MgNO3, magnesium nitrate. Okay, so pause the video and try the next ones. When you restart the video, I'll have the answers written down. You can try them and see how you do. Now again, don't be afraid to try, even if you're not sure. If you make a mistake, that's one way of learning. Okay, and good luck. Okay, let's go over the answers for these. So let's look at this one here. Okay, so you have an ammonium ion and a phosphate ion. And when I wrote it, I put 3 ammonium in the formula, NH4, with parentheses around it, subscript to 3 to indicate I have 3 ammonium ions, and then 1 phosphate. Why did I do that? Because the ammonium ion has a positive 1 charge. The phosphate ion has a negative 3 charge, so we need 3 ammonium ions to, if you will, cancel out the negative charges of the 1 phosphate ion. Okay, and then I write it, it's ammonium phosphate. The next one, iron, and then chlorate. I wrote it, I have 1 iron and 3 chlorates because the chlorate has a negative 1. The iron is a plus 3. I need 3 chlorates to cancel out the charge of the positive 3 iron. And when I write the name, I had wrote iron 3 in parentheses, chlorate. The next one, aluminum. Aluminum has a plus 3 charge. And my oxalate has a negative 2 charge when I wrote the formula. And again, the easy thing to do is to cross the charges. So if you take the 2, cross it over here to the aluminum. The plus 3 charge aluminum, I cross it over here. And I have 3 oxalates. So I write the formula, aluminum 2, and then oxalate, parentheses, 3. And it's aluminum oxalate is the name. And the next one, tin. Tin has a positive 2 charge, and my hydroxide ion has a negative 1 charge. So again, you can cross the charges. I have tin. It's understood to be 1. And 2 hydroxides. I put parentheses around the OH to indicate. I do that if there's 2 or more. And this indicates that there's 2 hydroxide ions. And the name is tin hydroxide. And then the last one, cesium, chromate. All right, I realized that I wrote cesium chromate, but it's carbonate. All right, so I corrected that. So you have CS2, CO3. The charge of the cesium is +1. The carbonate is -2, so I need 2 cesiums. It's the 1 carbonate when I write the formula, so it's a CS2, CO3. I didn't put parentheses around the carbonate because there's only one of them. I don't need the parentheses in that case. And then the name is cesium carbonate. All right. A practice. You can practice by trying this multiple times, by pausing the video, writing your answers, and seeing how you do on them. Okay. Thank you.